I'm Juha Nurmi. I'm from Tampere University, from Networking and Information Security Group. I'm postdoctoral research fellow there, and I'm the prime investigator from Tampere side for SafeHorizon project. And as said, we are getting our funding from the European Commission, and we have promised the European Commission to have training exercises and public webinars as well. And that was one of the reasons we wanted to have this session as public one. Now let's jump to the content. I try to keep this session as hands-on as possible. So while I'm explaining the technologies, I'm actually showing the relevant tools and how they operate and explain them through while showing them. We are going to test the Tor browser. So in the email I actually provided you a link if you want to install and test Tor browser during this training. So I understand that some of you are using your work laptop and perhaps you cannot just go and install a new browser. But if it's an option for you, then you can do it. So Tor browser is basically a version of a Firefox web browser, but in a way that it hides your private information, your IP address, and the information that a regular web browser is showing. So it's safe to actually install, and it's a legal tool for anonymous browsing. That's why I offered the link. Well, we are going to visit something that people call a dark web, and they mainly mean these onion websites that are available on this anonymity network. Then we are going to actually test to set up an onion service and share some resources and look what the tools can offer, what are the easy methods to use these onion services. Then we are going to study a little bit about Tor statistics, look at weaknesses on this ecosystem from de-anonymizing users' point of view. We are going to check a little bit about the cryptocurrencies and the illegal trade on the Tor network. So the first part is the Tor browser, and I'm going to demonstrate how to use it. It's a free web browser which is a modified version of a Firefox browser, but it hides your information, especially your IP address and other information your web browser is typically providing. So let's compare a situation. This is a normal regular web browser now on the screen, and if I visit, in this case, a search engine duckduckgo.com and simply search IP, it will actually return my real IP address. So this is how normally all the web browsers are working. And if you're visiting any website, they will know your IP address. And the IP address is a networking address for internet connections, and it's typically connected to specific location. So for instance, this screen already returns to me that location is in Tampere in Finland. And if you go deeper, for instance, ask from the internet service provider, the internet service provider always knows that where this IP address is connected. So for instance, my internet service provider would give my home address if law enforcement would ask who is this guy with this IP address. Then if you compare the situation with the Tor browser, first of all, when I'm visiting the same DuckDuckGo search engine and enter the IP, it will actually return information that IP address is unavailable. That is not actually true. What it means that this particular search engine notices that this IP address is not a regular one. It belongs to the Tor network. And when I visit actually a website that gives me the permission, it displays back to my IP address, it returns an IP address connected to somewhere else that is not Finland. So in this case, this is a Tor browser, and I'm visiting one of these websites that are showing back my information. The information it gives back is that my IP address would be located in United States, in California, in San Francisco. So this is not my real IP address. I'm in Finland right now. And what else? Typically, when you are using a normal regular web browser and visiting any website, your web browser actually tells any website automatically what is your screen resolution, what is your operating system, and even what is your hardware, underlying hardware, and in detail version of your web browser and your keyboard. And that's quite a lot of information. So consider that even without IP address, let's say you are a clever person and you are using VPN. And VPN effectively hides your IP address in the similar way as the Tor does. So it routes your traffic through some server, and wherever you are going, the endpoint only sees the IP address of the server that is passing your traffic through. This is how VPN works. Nevertheless, when you are using your regular web browser, Firefox, Edge, or Google Chrome, the web browser is still telling the in detail information what is your graphic card, screen resolution, keyboard, and operating system. And if you put all this data together, think about it, in my case, even without IP address, it would tell that I'm using Fedora Linux, I have certain graphic card, and I have certain kind of screen resolution, and my keyboard is a Finnish keyboard. I would say that even this information alone would fingerprint actually my machine. So the Tor browser does not return the real information about your computer. It tells that this is a Firefox browser and something else than your real web browser, your real operating system. It doesn't reveal your keyboard layout and these details. So how does Tor actually hide your traffic? And what's the difference to using a VPN? Well, actually in the Tor browser there is this logo next to the address, and when you click it you can actually see the current routing to any website. So let's say here the route that the Tor browser is using goes to Poland, United States, and the Netherlands before it reaches to ahmia.fi. And as a result, there is no one point of failure. So typical question is why this is safer option to hide the location than the VPN. With a VPN, you only have one server there that is passing through your traffic. And as a result, obviously, the VPN server knows your real IP address and it knows where you are going. So potentially the server could follow everything you do and it would know all the places you are visiting. Then if you compare this situation to Tor, where there is actually 3 servers between you and any website you are visiting, this means that the first relay or node or server in this chain knows your real IP address, obviously because you are connected to it. But it's only passing traffic to the next server. So the first server doesn't know where you are actually going. It only sees that there's traffic coming in and it needs to pass it forward to the next server. And the next server, in this case in United States, only sees that there is traffic coming from a Tor relay or node. We call these relays or nodes. And it's passing the traffic to the next server that is in this case in the Netherlands. And the final server sees that somebody is visiting ahmia.fi. But the server in the Netherlands cannot know in any way who are you. It doesn't see your IP address anymore because there were these other relays in the chain. So this is the main technique Tor is using to hide your IP address. Similar to VPN, but more relays. And you can actually check this information from the Tor browser, from this logo. So let's look at the diagram of the situation. The Tor client in many cases is the Tor browser, and it's connected to something called an entry card node or relay, which is the first place where the connection goes. It's the connection from your web browser to the Tor network. Then it passes this traffic to middle relay, which is in the middle in the 3-hop chain. And this middle relay is passing the traffic to something called exit relay. And it's called an exit relay because it allows connections outside of the Tor network. So for instance, in this case, you could use Tor browser to reach wikipedia.org, and your connection would go through these 3 hops. And from the exit relay, it would go to wikipedia.org. And obviously, the wikipedia.org website server would see the IP address of the exit relay, not yours. So what else? The connections between you and the relays, these are encrypted. And these are actually encrypted with a layered encryption in a way that your Tor browser is creating a separate encryption layer between each of the nodes. And what does that mean? It means that when you are connecting to the first Tor node, it will peel off the first layer of the encryption, and it sees that there is a traffic that it needs to pass to the middle relay. But the traffic is still encrypted with the middle relay's encryption layer. And the middle relay in this diagram gets the traffic, and it opens its encryption layer and passes it on to the exit relay. But again, the information is still encrypted with the exit relay's encryption keys. And as a result, if you think about it in the point of view of middle relay, it doesn't actually learn anything valuable because it's only passing encrypted traffic of the Tor network without seeing the original IP address who sent it. It only sees that it needs to send it forward to another relay, so it doesn't learn where the connection is going. Then the final step, exit relay, it actually removes the encryption layer, and in case of reaching something like wikipedia.org, the exit relay would only see HTTPS connection going to wikipedia.org, and it would learn that somebody using Tor network tries to browse wikipedia.org. This is clever because this means that there is no one weak point that if it's compromised, it would compromise the user's anonymity. So in the case, let's say entry card is compromised in some way, it's spying traffic of the user. Well, it can only learn who is using Tor. It doesn't see inside the encryption how they are using Tor. Are they, for instance, reaching some website? This is the same case with the middle relay. It's only passing traffic through. Well, if you think about it, if exit relay is compromised, it will learn that somebody using Tor network is reaching a website, but it doesn't learn the user. And this is the trick that makes the anonymization of a user very complicated, because unless you are able to somehow spy the first point to the network and the last point out from the network, it's very difficult to de-anonymize what the users are doing. And what are these nodes? Where are they? Well, there is around 7,000 of Tor relays across the planet. And these are actually voluntary people running a Tor relay. So they are basically using the Tor software, but changing the settings in a way that they are setting up it as a part of taking the traffic transformation of the Tor network. Normally, when you are using Tor, you are using it in the client mode and you are not participating in any way transferring other people traffic. So if somebody wants to run a relay, they need to reconfigure their Tor and install it perhaps to some server, and they can act as a Tor relay, voluntary, passing through other people traffic. And people do this on voluntary basis. Perhaps most of them try to think that this is a beneficial functionality for society, because there are actually beneficial use cases for Tor. Well, obviously, anonymous web browsing, it can be very useful in many situations. Then there is the question of circumventing internet censorship. So if you actually look at this diagram and think about how a censorship system is working in China or in Russia or in Iran, they are censoring websites. So for instance, Russian Federation is in these days blocking access to Western news website. I believe that something like bbc.com is censored in Russia, or at least it was. So how the censorship system is doing this? It's basically blocking access to the IP addresses of bbc.com. bbc.com is a news website. It runs on a server, so obviously it has an IP address, how it communicates with the internet. The other thing that these kind of censorship systems are doing, they are blocking access to DNS system. So there is a system that resolves bbc.com to certain IP address. And if you block DNS queries to this system, people are not receiving the actual IP address to reach the bbc.com's web server. So censorship system is blocking access typically directly to the IP addresses and to the DNS queries. And if you look at this picture and think about it, in this case, a user that is reaching bbc.com from Russia is not directly connecting to bbc.com. The connection goes to the Tor network first. And in many cases, this is the method how Tor works, a very useful tool to circumvent internet censorship. So with a Tor browser, you can reach the websites that are censored in some country, because the traffic is routed through the Tor network, and through that road you are able to reach the website. Well, what often happens is that a country that applies censorship is often trying to censor the Tor network as well. How they do that? Well, as we explained it, there are Tor relays across the world. These are voluntary people running Tor relays, and actually you can fetch a list of all IP addresses of these relays. And if the censorship system is blocking connection to these IP addresses, then effectively the user has troubles reaching the Tor network. Well, the Tor browser is more clever than that. It will notice that it cannot reach now the public relays of the Tor network. It will immediately offer the user an option to use unlisted nodes that are not public to again regain connectivity to the Tor network. It will also offer the user an option to use something called traffic obfuscation, meaning that the connection to the Tor network is camouflaged to look something else than Tor protocol. And this is there in case the censorship system tries to detect connections to the Tor network and cut them down based on that they look like Tor protocol. So by camouflaging these connections and routing the traffic through nodes that are not publicly listed, you can actually gain access again to the Tor network and circumvent the internet censorship. So what did we learn? Tor, the onion routing, it's using 3 hops to connect to regular websites, for instance. It is actually supporting all TCP-based internet traffic, which means it's basically supporting many protocols that applications are using. You could run most of the traditional internet applications behind the Tor network. For instance, you could run your messenger behind a Tor network. You could use even this kind of you could set up your own video server or something like that behind the Tor network, something very different than the web browsing, because on the underlying level Tor is a system that is supporting anonymization for TCP based applications. It's a peer-to-peer network, so although you as a Tor browser user are not participating the peer-to-peer protocol, behind it the relays together are forming a peer-to-peer network, and they are like negotiating together how they transfer traffic, and they readjust and optimize the network in a way that users can reach nodes or relays which are not overwhelmed by traffic, and so on. Then there's this special ability to operate anonymous onion websites on Tor. This means that in the similar way that you as a web browser user, you are able to use Tor browser and your traffic is routed through the Tor network, you can do the same trick with your web server. So any web server is actually a computer. It's connected to the internet. It has real IP address. But if it's setting up itself to run behind the Tor network and creates this kind of onion address, then it can operate anonymously behind the Tor network. You can, of course, only reach it using something like a Tor browser, because the website is only available inside the Tor network. The encryption between the relays, it's established separately with all the relays. And this creates a layered encryption scheme where you have exchanged the encryption keys separately with each node. And you kind of start to guess why Tor logo is an onion. There's a reason for showing always the onion logo. Well, the reason is because there is this layered encryption scheme. So like the layers in the onion, you have layered encryption. So let's visit some of these onion websites and look what is the situation. So for instance, this is ahmia.fi, but I'm actually serving it as an onion address as well. It's the same website, but it's also available through different address, and this is a long random string .onion. And this address wouldn't work with my normal regular web browser because it's completely behind the Tor network. And if we look the circuit, now the situation is different than with a public website. The traffic doesn't actually go through any exit node. It stays inside the Tor network, and I can see that the Tor circuit for my web browser is consisting of these 3 hops. And then it says that there are other relays between this onion address and my last relay. So the onion website actually has its own 3 hops in the network, and as a result, there are actually 6 relays between my web browser and the onion address, and this provides anonymity for both. So of course I'm anonymous because I have my relays, but the website is also anonymous because it has its own Tor relays. Well, in this case it's not really anonymous because there is my name on the website, but technically speaking the protocol goes through the Tor network. Well, obviously, then if somebody runs a website inside the Tor network through law enforcement operation, it's very difficult to close it down. There is no mechanism in Tor to take it down, and it's very difficult to reveal the real IP address of the server that is running the onion address, and thus without the IP address it's very difficult to locate physically where this website is. It's difficult to even say in which country it is, and this causes the pain for law enforcement to take it down, and it requires really effort and in many cases mistakes from the operator of the website to be able to easily de-anonymize it. Well, one question is why Onion website is using its own 3 relays? Because it wants anonymity. Then why 3 relays? If you think about the image here, we have 3 relays. Often people ask that wouldn't it be more secure actually to add more relays here? Perhaps 4, 5 or more. Well, in some cases, yes, that could little bit help with the anonymity, but this would consume more resources from the voluntary nodes because you would bypass the traffic through even more nodes, and they have limited capacity to move the traffic. Then if you think about the best attack against the user, it is that somebody controls the entry card relay and somebody controls the exit relay. Then this kind of attacker can try to correlate incoming traffic and outgoing traffic. So because everything happens in real time, when you are accessing Wikipedia, you are downloading the website that has a certain site, and you are perhaps downloading the resources from there, like the images. Your web browser is doing that on the background. If somebody is correlating the traffic pattern in the entry card node and the exit relay traffic pattern to wikipedia.org. These happen almost simultaneously, and the traffic pattern is identical no matter is it encrypted or not. It looks similar. And if somebody has simultaneously control over the entry card node and the exit relay, then this kind of traffic correlation is possible. Now back to the question, why 3 relays? Well, if you have, let's say, 6 relays, you are somehow able to add more middle relays for yourself. Again, if the attacker is controlling the first point of the network and the point where the traffic goes out from the network, the attack is the same no matter what, how many middle relays you are running in the net between the first point and the last point. So adding middle relays is not actually protecting the user from the most powerful attack against this kind of anonymity system, and that's the reason that they selected actually 3. Little bit about onion services. So .onion address is not obviously normal domain ending. So typically you have websites like org, .com, .fi, .eu, and these work with a regular web browser. With Tor, they actually run inside the peer-to-peer network a name service like a system, and these domain names only work with Tor. And when you are accessing some onion website, then it's fetching the information from distributed hash table between the nodes and encrypting the traffic between you and the Tor, between the onion address. And you already learned that it's of course difficult to censor or take down or locate this kind of onion address because it's completely inside the Tor network. Interesting question is that often if you look onion websites, most of them are not using HTTPS at all. But why is that? Like, everyone has learned that HTTPS is the secure way to reach websites. So why almost always onion websites are not using HTTPS? There must be a reason for it. And the reason is because, again, everything stays inside the Tor network, and each link between the relays is encrypted, and there is a separately encryption layer in the traffic transfer level between your Tor browser and the onion website. And because there is already encryption layer, because it's Tor protocol, there is no actually need to use HTTPS. It does not add security in this case. Then the question is how the system is somehow behind the curtains matching the right encryption keys and these onion addresses. Well, the reason is that internally each onion address has its public and private key. That means that there is a key to encrypt the traffic and key to open the traffic. Public and private key encryption means that there's completely separate keys for encrypting and decrypting, and the key that opens the encryption is private, but the key to encrypt the message is public. This means that anyone can use the public key, encrypt something, but only the owner of the private key is after that able to open the encryption. And because the onion addresses are sharing their public keys internally inside this Tor network, the users who are encrypting the traffic with a public key matching to certain onion address know that only the owner of the onion address can open the encryption with the private key. And the onion address itself is a cryptographic hash sum of the public key, which means that if somebody has the matching private key to the public key, there can only be one onion address that is matching to this public key, and it's the checksum of the public key. So internally, the system verifies that you have a public key, and the checksum, the hash checksum, is matching to the onion address name. Thus, when you send the traffic there, you know that there is the right owner of the address receiving the traffic. Nevertheless, there is obvious problem with onion addresses, which we can see here. No human can remember these. They are not meant for humans to remember. And as a result, obvious problem is that if somebody replicates this website and starts to share the onion address to their copy of this website, then users have great difficulties to find the real onion address for instance, in my website. And they could easily go to scam websites. So this is the same situation like what we have with online banking. In many cases, some attacker is creating a similar name that is the real domain name for your online bank. And if you go there, the criminal is just stealing your money. So the same situation with onion address, especially it's even worse because you cannot even say by looking the onion address, is it the correct one. Now let's look a little bit about how to set up a simple onion service and how to access it. There's this software called OnionShare, which I'm testing on the background, which gives you 4 functionalities. You can share files, you can create an onion address that is sharing a file, you can receive files, so you can create the kind of Dropbox with an onion address to receive files. You can host a very simple website with OnionShare, or you can create something like anonymous chat. So let's test it. And it is asking me questions. Do I want to disable? Do I want to create a public OnionShare address? Disable the key. Or let's do that. Or set a separate password for this chat. I'm now copying this address and sharing it in the chat of. And if somebody now is using the Tor browser, you can actually try to access this chat. I will do the same thing, opening it with my Tor browser. And there is a simple chat. I see that we actually have some people in the audience at least testing this. And we see that the chat is working. I created very stupid anonymous pseudonym, which includes my real name, Juha Anonymous. But as you can see, this is a very simple way to set up onion address and use it for something like a chat. So I just made 2 clicks and I am running anonymous chat. We can keep the chat on. Here I tested the other feature, creating a website there I clicked start hosting and selected some files and created a website. Again, I will copy this address, and it's actually this website. We have a SafeHorizon website for this meeting now inside the Tor network, and I will share the link with you to test. This is not the real way to create websites, by the way, because now this system is able to share static files. So although this is a website that would work to display information, it's the kind of website that you cannot add any background information there. You cannot run a database there, so you couldn't set up a system where the users are, for instance, somehow saving information there, or there is a server that is interacting with them, or so on. But with very simple information sharing, you could use Onion Share. We could create a Dropbox like system to receive files or share files. Perhaps in this case I'm creating this kind of system where people could send data, and if I'm not selecting this, making it public, then it will actually create a separate passphrase. So in order to send data to this Dropbox, you need the password. So again, there could be a lawful good usage for this kind of situation. So you could think about that there's a journalist that wants to receive, let's say, files on corruption, or even law enforcement wants to have some kind of online tip line and receive information. They could run it as an Onion service. Then they would ensure that even they are not learning who is sending files for them. So all these tools are actually developed for lawful purposes in mind to benefit society. Nevertheless, of course, criminals are exploiting all of these tools for criminal activity. The main motivation behind creating these has always been that there are users who want to perhaps browse web anonymously, or they need to circumvent internet censorship, or they want to set up something like a chat or file transfer in a secure way and provide real anonymity for a user. Then, if we look more technical wise, I'm not now going to set up one, but you could set up, for instance, SSH server, which is remote connection to Linux computers, especially Linux servers. You could run this kind of service with an Onion address. And the interesting question is that typically when you are running a public service, public to the internet, you need to somehow get through firewall, or people who are connecting to you need to get through some firewall system, or set up some port forwarding in the firewall, or network address transformation system. So typically, let's say you are at home and you would like to set up remote connection to your home computer. You could do that with Tor without changing the firewall rules. And the reason is that in this case, the connection again goes completely through the Tor network. And Tor is actively making the connection to the Tor network. So you can run many type of remote access services through the Tor network, even behind firewalls, even without control, how the ports are forwarded to your computer. And this might be useful, for instance, if you want to set up remote connection to your home and you have some kind of system with the service provider that this is not easy to do, or you have a home router that is not simply supporting opening ports. There might be a firewall system in your home router which you don't actually have control over. Let's see the chat. Is there something happening? The chat seems to work, and I see that total of 8 people are there. By the way, if you have any questions, please go ahead and ask anytime rather than raising your hand, because if you are raising your hand, most likely I don't notice it while I'm sharing the screen. But if you have questions, you can open your microphone and ask. Now let's look a little bit about how large is the Tor network and why it's relevant. We can actually see the metrics of the Tor network from the Tor project. So the Tor project is non-governmental organization that is developing the Tor browser and the Tor network itself. It's maintaining metrics to look. And you can see how many users are using Tor. You can see the number of servers that are transferring the traffic, so-called nodes or relays. You can see how many onion addresses there are. There is almost 800,000 onion addresses in the world. We don't actually know what most of them are doing. So it's completely unknown what is the functional purpose of all these onion addresses. It seems like that they are most likely not providing any web content, because the number of onion websites is much lower. It's perhaps less than 100,000, but the number of onion addresses is huge. So most likely people are running these onion addresses for other purposes than providing at least public websites that they share with someone. Then number of users. There has been spikes. Nobody knows why, again, because these are anonymous users. But on average day, there is around 2 million Tor users. And this is relevant because if you are running an anonymity system, one requirement is that you have a sufficiently large user space, meaning that simultaneously there are a lot of users in your anonymity system. Because if you are running an anonymity system where is only a small set of users using it, this would mean that any kind of de-anonymization attack would be easy. Or if you would run a system that, for instance, only criminals are using, then law enforcement could just check that everyone who is using this application, they would perhaps detect the internet protocol. They would be able to say what a certain user is doing if it's like a system for one purpose and it's only for illegal purposes. But in case of Tor, because there are many users who are just browsing web or doing something legal there, we cannot just take internet traffic and look who is using Tor and then say that these are criminals, because the user space is quite high. Every moment there is 2 million users connected to the Tor network. Now, I mentioned that Russia censored just before attacking the Ukraine. Russia censored access to news websites and even to Tor Network. This happened actually in December, before the war. So like 3 months before the war, suddenly Russia started to censor access to the Tor network and news websites. So let's look from the traffic point of view. How does it look? Russia. There. And I will go back in time before the, let's say, much before the war. We can see the statistics before the censorship of the Tor network and after it. So before December in 2021, there were more than 30,000 users from Russia. And then Russia implemented a system to start blocking access to the Tor network, meaning they started to block access to the public IP addresses of publicly listed Tor relays. And of course, the connectivity to Tor started to go down very rapidly. Reason that it's not going down immediately and completely is that, as far as I understand, in Russia they don't have one system in place to block traffic. They actually give orders to different internet providers to do something to block access to resources. And because there are a lot of internet service providers and they are technically implementing this as they can, it's not like one system blocking the access at once. It's many internet service providers doing something to block the access. And that's why you can see that although the connections has collapsed down, there's even some connectivity left. And these are now the public relays against which the system carried out the censorship. As I mentioned, the Tor browser is actually detecting this and offering the users way to access the Tor network again, but with relays that are not publicly listed. And we should here see completely another kind of graph. So yes, but you can see that when Russia started to cut down connections to publicly listed relays, then as a reaction, the Tor browser started to offer these hidden bridges. These are called hidden bridges. They are not publicly listed relays. And you can see that, let's take the Russia, that usage of these relays actually goes up when there is a censorship event. We should even see this more clearly with Russia. So yes, you can clearly see like the censorship event here. It happened in December, and immediately many Tor browsers switched to use non-listed hidden bridges to access the Tor network and circumvent the censorship. And the number of users using these hidden connections to the Tor network is increasing all the time to circumvent the censorship. It's good to notice that Tor are very good for just for this purpose, because most likely there is also some kind of surveillance going on. So most likely surveillance system tries to look who is using Tor. Well, if you are using the traffic obfuscation method, then this is very difficult to notice that this is actually Tor connection. And even in that case, let's say they find that there's a user who is using Tor network. The connection is encrypted, and as a result, the surveillance system in the state, like in Russia, would not learn that the user is accessing bbc.com. the surveillance system would only learn that somebody is connected to the Tor network. Oh yeah, the number of relays. So I mentioned that there's something like 7,000 relays. Actually, it seems that in these days there's already around 8,000 relays across the world. This means that in all the major countries there are multiple relays, and by using these relays the traffic is routed safely through multiple countries. And actually the traffic is typically circumvented through multiple countries, like here. And the reason is that in the protocol level, when your web browser, for instance, is selecting these 3 nodes, it's doing it at random, but it tries to actually select the internet addresses, IP addresses from far away each other. Meaning that, for instance, if there is a set of relays in Germany approximately under the same network, which you can see based on the IP addresses, then this algorithm is avoiding selecting all the relays from the same subset of the network, and instead it's trying to get a route through multiple networks, and this yields to a situation that typically the connection goes through multiple countries. One result for this is that, let's say there is one country carrying out very deep internet surveillance, and another country doing that as well. If they don't collaborate together, they are not in meaningful sense being able to de-anonymize the users. So if you think about the scenario that somebody is able to spy the first point of the network, the card, node or relay, and the last point of the network, it needs to be the same entity basically, or entities exchanging information together. Otherwise they don't gain any meaningful information from this. And this is basically a traffic and timing correlation attack. So as I explained, Tor has weaknesses. One of them is that if somebody has control over the whole network, then of course the situation is very bad for the user. Then the attacker can follow the traffic in the network. But to reduce the case from this is that somebody has access over the entry node and the exit node. And there are 2 ways that the attacker has this kind of access. The first one is, of course, that the attacker is running the relays. Then obviously the attacker has control over seeing the traffic coming in, and if they are able to also run the exit node that the user is using, then they are able to correlate it. The other option is that there is an attacker that is capable of spying a traffic, let's say in the state level or across multiple states. Then this kind of attacker would be able to correlate incoming traffic to the relay and outgoing traffic from the Tor network, and see if there is a correlation, the same pattern, same sizes of internet traffic at the same time, and make a guess that with a strong likelihood this is the same. This is the user entering the Tor network and exiting from it. And in that case, of course, the attacker who has that kind of capability look over all the internet traffic in the country. The attacker doesn't need to run the relays itself. There has been many cases where the Tor Project Foundation has removed relays from the Tor network. And the reason is that they have noticed that there is an entity that seems to run suddenly a lot of relays in the Tor network and trying to gain a position where they run a large part of the network, and thus they would be at least de-anonymize some of the users. So through the years, there has been situations that the Tor Project Foundation has noticed at this situation, that these relays are installed at the same network suddenly, or are somehow under control of the same organization. And the Tor project has a control over removing relays from the Tor network. They do this to prevent the situation that somebody is controlling a lot of these relays, or if somebody on purpose sets relays that break somehow Tor protocol and misbehave, try to cause chaos, then they can manually remove these relays, and they have automated systems to detect misbehaving Tor relays. Nevertheless, traffic and timing correlation attack is possible, and sometimes it can be more small scale and easier than a state level attack. I can give you one example, for instance. So there was years ago a Harvard student who sent a bomb threat to the university when the final exams were taken, in order to, of course, move the final exams to another day. And this student sent it an email using Tor, and when they received the bomb threat, they noticed that actually the IP address is a Tor network IP address, and the email is coming from anonymous source. And effectively, with this information, you cannot find who sent the email, unless you suspect that there's a student who sent the email. And indeed, they in that university in Harvard, they actually have a mechanism to log connections, and they noticed that only one student accessed Tor network just before this email was sent, and after that closed the connection to the Tor network. So from a university network, same time as the email arrives, one student is using Tor. Okay, the student still has plausible deniability. Of course, this does not prove that the student sent the email, but in this case, the FBI obviously went to ask, and this student confessed that it was him who sent the email, the bomb threat, in order to move the final exam. And this is in small scale one example how traffic and timing correlation attack can take place. So it doesn't necessarily require some kind of state level system looking all the internet connection. If you have tips that this might have been an event from this network, and if you have another system looking that there's one person using Tor every time, or the one time a certain event take place, you can correlate this. The another type of attack is actually that web browser itself, it's just software, and web browsers often have vulnerabilities. So no matter are you using Microsoft Edge or Firefox or Google Chrome, these browsers are getting security updates almost daily, if not daily, at least monthly level. And this means that they are basically improving the browser all the time. The Tor browser is based on Firefox browser. It's using the same code as the Firefox browser. And if Firefox browser has something called zero-day vulnerability, meaning that there is some vulnerability that is not fixed yet, if somebody can exploit Firefox browser, in many cases the same attack works against the Tor browser. And this kind of attack has happened at least 2 times in quite large scale. So it's actually even documented in the email exchange in the Tor talk mailing list, where somebody notices that there is a Tor website running very weird code. So there is something very weird inside the JavaScript code that the website is providing, and it's running very weird operations, and they notice that actually this is attacking against the web browser in a way that it's able to execute inside a web browser a certain type of call that is escaping from the sandbox of the web browser and able to execute code that sends the real IP address of the user, not the one that Tor is using, but the real one to some server. And this kind of attack, of course, can then de-anonymize the user because it's sending the real IP address to somewhere. So always, of course, the web browser, it can be vulnerable, and if it's vulnerable, then it's possible to exploit it. Then technical failures in setting up Onion services. If you look back the history, many people have tried to run illegal activities on Tor, and they have made a small mistake when they are setting up their website, for instance. And this yields to a situation that easily the website is leaking some information that can reveal the real IP address or something else about the server that leads to eventually that law enforcement is seizing it. This seems to happen over and over again. So the learning outtake from that is that it's not that easy after all to set up Onion website and keep it safe, because people tend to make mistakes there, add data there that contains their details, or technical mistakes. And one reason is that when people use Onion services, for instance, to set up a website, they are still using the same web frameworks and web servers that are designed for normal web pages. And let's say even you have seen this situation probably in your life multiple times. You visit some website and the website is saying that there's an error situation going on. It's not functioning as it's supposed. And in many cases, the website is printing to the end user a large log that this database connection is not working. This is the kind of query that failed to execute there. And these are all the error logs that are happening behind the server operating. And you have probably seen many times that website output this garbage to you saying that this is all the error logs. In many cases, these error logs are containing in detail information how the website works, in detail information of the server itself, and sometimes even the real IP address of the server. So in the early days of illegal trade on Tor, the first original Silk Road, which was a marketplace for illegal drugs, actually suffered from multiple situations like this, and including a situation where the server actually displayed the public IP address of the server in an error situation. So, because normally this is not catastrophic for a website, so if you have a university website and it's saying that this server in this public IP address is not working correctly, it's not a problem. It's not revealing something useful for some attacker. But in this case, it's different because it reveals the real IP address, thus the location of the server. And the reason is that these softwares that people use with their onion address are not simply designed to provide anonymity for the website. And eventually this operator of the first illegal marketplace inside the Tor network got caught and was sentenced because he made multiple errors like this, and the law enforcement was able to catch him. Now we come to the illegal marketplace. So because it's a relevant topic, because everyone already knows that on the dark web, which basically means Tor, there are these illegal marketplaces, mostly selling illegal drugs, but stolen information as well, digital goods, malware and hacking tools, hosting services and other items, frauds, databases, credit card information, passwords, you name it. Let's take a look of these marketplaces. As said, most of them are the most common item in these illegal marketplaces seems to be illegal drugs. So let's start from that. The illegal drugs that are available closely reflect to the drugs that people are using. So if you compare this data to other data sources, you actually notice that, as you can see, cannabis and stimulants are the most popular kind of illegal drugs. This is the same situation if you look some completely other data source. You, for instance, take wastewater from a city and measure from the wastewater what drugs, illegal drugs, people are using. You see somewhat similar results: cannabis, stimulants, and after that prescription drugs and dissociatives, ecstasy, and so on. At least in Finland they actually measure the wastewater to create the statistics over what illegal drugs people are using, and it correlates well to what is available on the Tor network. How does a marketplace look like then? So it looks like an eBay or Amazon, but for illegal products, and it's obviously available only through the onion address, not through a public website. And there the products are offered for sale using some cryptocurrency. So this was a Nemesis marketplace. It was using Bitcoin, Monero, and Litecoin as payment method. Then there are sellers who set items for sale. And there's a reputation system. So for a seller, you can actually check the seller's ratings. The buyers are giving ratings to the seller, and you can look the reviews. They are giving feedback to the seller, and the number of sales the seller has done. And based on this reputation metric, the users can at least check what was the previous reputation of a certain vendor. They can also check most of these websites where the seller is shipping from and to where. In case of Finland, at least this part is relevant because Finnish custom service is very effective to find illegal trucks. So if somebody tries to order through mail trucks, illegal trucks to Finland, there's a high likelihood that Finnish custom service is actually catching the trucks. And as a result, in case of Finland specifically, many people seem to prefer buying illegal trucks inside the country because then the vendor is sending the item through mail, but in this case through domestic mail in Finland. It reduces the likelihood that the package is scanned in any way or intercepted by the law enforcement. As said, all the illegal trucks are available through these kind of marketplaces. So we are now seeing some kind of nemesis item showing MDMA, and the seller is located again in Germany and shipping worldwide this product. The payments are done in cryptocurrencies, Litecoin, Monero or Bitcoin, and the system works in a way that if somebody is planning to buy something from this kind of marketplace, they need to actually deposit the cryptocurrencies to wallet system of the marketplace before trying to order anything. And when they order something, the system locks the payment from their wallet, but it doesn't actually immediately give it to the vendor. Instead, it's only locking it and waiting typically that the buyer gives a positive feedback to the vendor when it's releasing the payment to the vendor. Or the marketplace administration can resolve the matter how they see it fits. But the mechanism is there to ensure that users are giving the feedback and ensuring that the vendor has a reputation metric to follow and the vendor doesn't immediately get the payment, that at least there is some mechanism to limit the fraud between the buyer and the vendor. And this is obviously needed in this kind of system because there is no lawful way to try to get back your money if you're sending it to some vendor. Nevertheless, many vendors and even marketplaces scam money from the users. These marketplaces seem to offer also other items, illegal items like firearms. Although I must mention that this category is not offering typically many items. So the number of, for instance, illegal firearms is relatively low. We are now talking about that these are available, but the number of items is very low compared to the thousands of advertisements for illegal trucks. As mentioned, stolen information is available. So credit card fraud is typical, meaning that there is some system that is stealing credit card information from users or stealing it from some database. Then the seller is selling this information, the credit card information, forward using some marketplace. And after that, perhaps there is those who actually start to exploit the information, meaning cashing out the money from the credit cards or something like that. Also, there's stolen information available, leaked data from organizations available on these platforms. As mentioned, the payment method it's cryptocurrencies. Again, it's now obvious that you cannot send the money use your bank account for illegal activities. But if you think about back in the days, for instance, Bitcoin is relatively new technology. It was launched in 2009, and before that, on the Tor network, there wasn't actually illegal marketplaces operating. And the reason was that there wasn't any payment method available. So Bitcoin was launched in 2009, and the first illegal marketplace, Silk Road, was operational in 2012 or 2013. So these illegal marketplaces appeared after there was a payment method, electronic payment method available. Before that, on Tor, this wasn't the thing, that there are these marketplaces selling illegal items. With Bitcoin, of course, the transactions are not anonymous. There's a pseudonymity, so when you are transferring money between Bitcoin addresses, they go from public wallet to a public wallet. Of course, if nobody knows whose wallet is that and whose wallet is that, it's hard to say who is transferring money to who. Nevertheless, this is a public record. So afterwards, if, for instance, law enforcement gains information that there was activity with this wallet elsewhere and it's connected to this person, they can look back in the history. Are there any illegal activities from this wallet and to which wallets? So Bitcoin blockchain is public record of all the transactions in the Bitcoin network. But there are systems which offer anonymity, at least some sense. So Jetcash and Monero try to offer anonymous transfer. It's not, however, completely bulletproof. So in case of Monero, there are techniques to try to correlate the likelihood of transactions. Nevertheless, there is no directly available public record to track who is transferring money to who. And when you combine cryptocurrencies and the method like Tor to publish website anonymously, then there are the technical particles in place to run illegal trade. So we can, in the theoretical level, learn from this that if there is no onion services available, it's impossible to run these illegal marketplaces because you don't have mechanism to easily publish anonymous website. On the other hand, if there is a tight regulation on cryptocurrencies and checks in place who owns them and how they are transferred, then again this kind of illegal trade wouldn't work anymore. So as an example, I mentioned that blockchain transactions are public. If we look blockchain transactions to donation address of the Tor project, we will actually see all the incoming transactions and when they took place. So some of them are happened today even. Okay, so there was somebody transferring something like $5 to the donation address of the Tor project. And this is public record. And if they transfer their bitcoins from this wallet, again it creates a public record to the blockchain. Of course, Tor marketplaces are aware of this. So many of the marketplaces are mentioning that the users shouldn't use Bitcoin, although it seems to be almost always available as a payment method because it creates a public record of transactions. Instead, they explain the different functionalities of other cryptocurrencies. Then they mention for people to use mixing methods for Bitcoin. And what is that? It means that there are these systems to mix transactions together. So there's like a pool of transactions, and when somebody transfers funds there, they will mix different transactions together, typically breaking them down to long chains and breaking the transaction to multiple transactions. So instead of transferring one Bitcoin from A to B, they're transferring it in small batches through different chains and mixing it together with other transactions. And this, of course, makes it more difficult to follow the transaction, although not completely impossible because the track is still there. Between A to B, there is now a long chain of transactions and multiple transactions, but eventually something goes from A to B. And these mixers are often using even chains of multiple mixers together. Because many of these operate on Tor, I would assume that some of them simply steal the money from the user, because it's very easy to claim on this kind of website that this is completely secure and the website is not stealing anything from you and everything run on client side or something like that. But of course, in reality, I would say that some of these websites are simply scams and stealing the funds from the user. Same thing with many marketplaces that claim to offer that they sell something. Some of them most likely just steal everything that they get from the user. Okay. We reached the last slide, and thank you for European Commission for funding the first webinar, which we held as a public event. I would love to hear questions from your side, and again, feel free to ask them aloud without raising your hand. So if somebody has a question, just ask it.
Yes, hello.
Hello.
Thank you, first of all, for this very interesting presentation. It was really interesting. My name is Kostas Tripolitis. I'm a software programmer from Greece. I would like to ask about the markets, darknet markets. How easy is to locate new markets? Or I'm aware that many of them change their addresses frequently due to avoiding being spotted by law enforcement agencies. So how easy is it to locate such markets through a Tor browser, let's say?
That's a good question. In many cases, they publish what they say this is our official .onion address. They share it on some forums, even typically in public web forums, that this is the correct address for the marketplace. And there might be something like history that there is some account on or profile on some forum sharing the link. And if it's like the same profile over time, it gives some confidence that this is the same person who actually launched the website because the first link came from him. So these are the kind of mechanisms that the operators of these illegal marketplaces try to have in place to tell what is the right address. Nevertheless, I believe many users are scammed because they simply go to wrong forum and find a link that seems to land a website that looks like the marketplace, but after giving their credentials in, there's an attacker who steals everything that was saved on their wallet on that marketplace. Thank you for your question. It was really relevant.
Thank you.
I see in the chat question about forensics tools. So yes, of course, law enforcement and forensics researchers has tools for Tor, and SafeHorizon project is developing a toolbox for law enforcement purposes, including what happens on Tor using different techniques. In this public webinar, we are not covering the tactics in detail, but these exist. And the SafeHorizon is going to provide tools for law enforcement through the agencies in Europe. So we have a pathway to do that. Any other questions?
Maybe just a quick comment. Hi, Juha. Hi to all participants. I'm Ivana from Privanova, project partner at SafeHorizon. I just would like to thank Juha for this presentation. I'm really impressed by the language used. So this is really very well explained in very, so to say, simple language, ordinary language, make us all able to understand what is it about, even those of us who are not computer scientists or something similar, which I think it is really important because the goal of the project is also to raise awareness about cybercrime as a threat. So I would just like to call all participants to follow the project social media pages, because we will make video of this presentation and post on our YouTube channel, and then you can go back to video and remind yourself on a presentation, or even share this presentation on your social medias, and so help us to raise awareness about not just the project, but the basically topics we are dealing at the project with. So thank you, Juha, again, and thank you all for participating.